Mystery of volcanic tsunami solved after 373 years. The explosion of the underwater volcano Colombo in the Aegean Sea in 1650 triggered a destructive tsunami that was described by historical eyewitnesses. A group of researchers led by Dr. Jans Karstens of the Geomar Helmut Center for Ocean Research Kiel has now surveyed Colombo's underwater crater with modern imaging technology and reconstructed the historical event. They found that the eyewitness accounts of the natural disaster can only be described by a combination of the landslide followed by an explosive eruption, and the findings are published in the journal Nature Communications. Now, the video before this one talks about the Hellenic arc of the Santorini Aegean eruption, and at the time of Moses, obviously, because of the huge eruption that took place there 3,600 years ago at the time of Moses, an exodus of Israel from Egypt, that must have had a tsunami as well. Drawing back the water, perhaps that's what caused the Red Sea retreating and then closing up again in God's perfect timing. Now, from the Greek island of Santorini, this article says the eruption had been visible for several weeks, and the late summer of 1650, people reported that the color of the water had changed and the water was boiling. Can you imagine? Water meaning, of course, the seawater. About 7 kilometers northeast of Santorini, an underwater volcano had risen from the sea and began ejecting glowing rocks. Fire and lightning could be seen, and plumes of smoke darkened the sky. And then the water suddenly receded, only to surge towards the coastline moments later, battering it with waves up to 20 meters high. That's 60 feet high. A huge bang was heard more than 100 kilometers away. That's the explosion of the volcano. Pumice and ash fell on the surrounding islands, and a deadly cloud of poisonous gas claimed several lives. We know these details of the historic eruption of Colombo because there are contemporary reports that were compiled and published by a French volcanologist in the 19th century, says Dr. Jens Karstens, marine geophysicist at Geomar Helmut Center for Ocean Research Kiel. But how did these devastating events come about? And to find out, he and his German and Greek colleagues went to the Greek Aegean Sea in 2019 to study the volcanic crater with special technology, Carson says. We wanted to understand how the tsunami came about at the time and why the volcano exploded so violently. On board the now decommissioned research vessel Poseidon, the team used 3D seismic methods to create a three-dimensional image of the crater, which is now 18 meters below the water surface. Dr. Gareth Crutchy, co-author of the study, says this allows us to look inside the volcano. Not only did the 3D imaging show that the crater was 2.5 kilometers in diameter and 500 meters deep, that's 1,500 feet deep, suggesting a truly massive explosion. Okay, that's how deep the crater was. The seismic profiles also revealed that one flank of the cone had been severely deformed. Critchley says, this part of the volcano has certainly slipped. The researchers then took a detective's approach, comparing the various mechanisms that could have caused a tsunami with the historical eyewitness accounts, and they concluded that only a combination of the landslide followed by a volcanic explosion could explain the tsunami. By combining 3D seismics with computer simulations, the researchers were able to reconstruct how high the waves could have been if they've been generated by the explosion alone. Carson says, according to this, waves of 6 meters, that's 6 was 20 feet, would have been expected at one particular location, but we know from the reports of eyewitnesses that they were 20 meters high, that's 60 feet high there. Furthermore, that's pretty high. I mean, that's people used to live on the coast there, so that means the coast must have been inundated. Furthermore, the sea is said to have first receded at another point, but in the computer simulation, the wave crest reaches the coast first, and thus the explosion alone cannot explain the tsunami event. However, when the landslide was included in the simulations, the data agreed with historical observations. Jens Carson explains Colombo consists partly of pumice with very steep slopes. It's not very stable. During the eruption, which had been going on for several weeks, lava was continuously ejected. Underneath, in the magma chamber, which contained a lot of gas, there was enormous pressure. When one of the volcano's flanks slipped, the effect was like uncorking a bottle of champagne. The sudden release of pressure allowed the gas in the magma system to expand, resulting in a huge explosion, he said. Something similar could have happened during the 2022 eruption of Hunga Tonga undersea volcano, whose volcanic crater has a similar shape of Colombo's. The study provides valuable information for the development of monitoring programs for active submarine volcano activity, such as Santori, which is led by co-author Professor Dr. Paraskevin Nomikou of the National and Kapodistrian University of Athens. We hope to be able to use our results to develop new approaches to monitor volcanic unrest, says Jens Carsons, maybe even an early warning system collecting data in real time, and that would be my dream, he said. And this is from Helmut's Association of German Research Centers on phys.org. It's very difficult, of course, to study and predict undersea water volcanic eruptions that could cause these tsunamis. You've got to be on top of them. How do you do that? This is on phys.org. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.